First of all, I would like to say thank you so much for the organizer to give me this great opportunity to meet you today. I am so happy to present my presentation, which is under the title Multiplicative b-homogeneralized derivation of associative ring. Maybe somebody asked, who am I? My name is Mehsin Atteya, Department of Mathematics, College of Education, Muslim University, Iraq. The main idea of my presentation, but wrote in this slide, where yes, in this manuscript we present multiplicative b-homogeneralized derivation on associative ring R and discussed certain differential functional identities having multiplicative b-homogeneralized derivation. Investigation the centralizer of suitable subset over a semi-prime ring that admit multiplicative b-homogeneralized derivation, enhancing some outcomes. In the previous literature, we prefer to read the references for and for more details about the background related subject. As is well known, the problem of linear mapping receiving fixed product is very interesting item in the field of operator algebra. The derivations that can be completely determined by the local action on some subsets of algebra having attracted attention of many researchers. The Martindale ring of quotient of prime ring R was introduced by Martindale in reference 6 as a tool for study rings satisfying polynomial identity. That concept was extended to semi-prime ring by a mixture. Historically, the study of derivation was initiated during the 1950s and 1960s. The derivations of ring get tremendous development after the Postner established two very striking results on prime rings. Here I wrote important question: when is a multiplicative derivation additive? This question was issued via Martindale even in 1991. An affirmative answer to this question was created by Dive, references 8, the details about this reference, where he introduced the idea of multiplicative derivation and provided. Further, in continuation of this study, Daif and Tamam Said presented the idea of multiplicative generalized derivation. They discussed a similar situation for the additivity of multiplicative generalized derivation. Recently, Mehsin investigated the behavior of certain differential identities involving three multiplicative generalized lambda-lambda derivation on the ideals of semi-prime ring, where he provided that a ring R has commutative ideal with the help of the triples F, F, and GG and HH. They are multiplicative generalized lambda-lambda derivation on ideals and semi-prime ring with some condition. Namely, that an associative ring R is semi-prime ring when R satisfied the relation R1 R equals 0 implies yields R1 0, and a prime ring when R satisfies the relation R1 R capital R2 equal 0, which supply two options there, either R1 equals 0 or R2 equals 0. As a factual information about the connection between the previous concept of prime ring and semi-prime rings, mentioned as following: a prime ring forms another kind of semi-prime ring, which is a semi-prime ring, while the converse, unfortunately, is not always true. Let Q sub MR and Q sub S denotes the right Ottoman quotient ring and right symmetric Martindale quotient ring respectively. A left ideal K of a ring R is said to be dense if for every xy in R with x non-zero there exists A in R such that A times x not equal 0 and AY belong to K. When a ring R admits for all R1, R2 and R satisfy the Lipin's rule, which wrote by this white wrote by use the red color, then a derivation that is an additive map. This is definition of derivation. Whenever for all R1, R2 and R there exists an identity, here D capital just look like the Lipin's rule, but just here D capital and D capital with D small. D small refers here to a derivation, and in this case we can say B is a generalized derivation. In 2000, a classical definition of homo derivation posted via a Sufi article, where he was describing the additive mapping a homo derivation concerning a ring R like psi from R to R satisfy this relation. Yes, here psi xy equal psi x psi y plus x psi xy plus x psi y. The difference between homo derivation and the derivation, look here, we haven't the R1, the R2, while in homo derivation we have psi 1, psi x, psi y. Where xy belong to R, an element of such a mapping is to relate here psi x, so psi x, take away x for all. This is a good example about the homo derivation. It's clear. It's clear that homo derivation psi is also derivation. When the homo derivation, I mean specific, the item psi x psi y equals 0, the homo derivation become equal to a derivation. An additive mapping F capital from R to R is called a right generalized homo derivation. Sorry, if there exists a homo derivation psi from R to R such that f of xy equal f of x psi y and f of x and f of xy plus x psi y for all xy and R. Moreover, a mapping from R to QMR associated with a derivation not need to be additive. D from R to R such that satisfy this relation f of sigma tau equal f of sigma tau plus P sigma, sigma D of tau, this is her type of her sigma, holds for all sigma tau and R. And for any fixed P belong to Q sub S, contain on all them contains in a QMR if F is additive, not necessarily additive, then F is called B generalized. Look here, when F is additive, we have B generalized derivation, while when F is not necessarily additive, we have multiplicative B generalized. Hence, one may be observed that the concept of multiplicative generalized derivation includes the concept of derivation and generalized derivation and the left multipliers. The left multipliers defined by this way. We have in this type left and right too, just swap between f of x and y. So it is should be interesting to extend some results concerning this notation for the notions to the multiplicative generalized derivation. Every generalized derivation is multiplicative generalized derivation, but the converse is not true otherwise. In the next slide, we will see the main definition which represents the generalized derivation of the previous definition. Here I put my main definition. Suppose that R is associative ring. F mapping from R to Q R associated with the homo derivation D from R to R such that f of sigma tau equal this expression for all sigma tau element in R, and B any fixed belong to Q sub S contain Q sub R. When F is not necessarily additive, then F is called b-homogeneralized derivation when her F additive, while when it is not necessarily additive, we will have multiplicative b-homogeneralized derivation. To be more close to the previous definition, we watch the following example. Here I take this, this is a set of R, be a ring of matrices over a field, and here define f of x capital and define f of x small. After make a simple calculation, we find D is homo derivation, homo after this is simple calculation. D is b-homo derivation of R. Moreover, we investigated for this formula. First time I focused to show this b-homo derivation, and after that I will test all my formula respect to F. Yes, and this is also. Now I post the main result. Before I start the main result, we have the notes. The symbol XY represent to the Lie commutator route by the formula, and Jordan commutator route. This is Jordan X circle Y, and this is commutator XY route by this way. Theorem 1, let R be a sim prime ring, K non-zero. There is ideal of R. Suppose F from R to Q to Q sub R is a multiplicative b-homogeneralized derivation associated with the derivation D satisfying the condition bracket of sigma of F of sigma with tau belong to Z of R. Z of R here refers to center of sim prime ring, and also P by the previous condition. Then either D is commutating over R, or we have the bracket sigma with B equal 0. Necessary, remember here D acts as b-homo derivation on R. Corollary, beside all the previous beside all the theorem 1, we have the corollary 2 R sim prime ring under the same hypothesis, but we replace the main condition by of sigma circle tau belong to Z. Then we obtain then either D is commutating of R or bracket sigma B equal 0. Proposition 3, suppose R is a ring, if F from R to R acts as a multiplicative b-homogeneralized derivation associated with the derivative D from R to R over R for any sigma which element of R non-zero belong to Z of R yields f of sigma belong to R. And if you are in 4, let R be sim prime ring, K be a non-zero is ideal. Assume also F is multiplicative generalized, such that F satisfy the expression F of bracket sigma tau equals 0 for all sigma tau in K here, and any B belong to Q sub S belong to Q sub S subset Q sub R, then either D is commutative over R, or we have the bracket sigma B equals 0. And the corollary also, because depend on the previous theorem before, we have the corollary 5, then we get the main result here, or the outcome here, either be acts as a centralizer of K or D of K equals 0. And theorem 6, suppose R is a prime ring and K and N0, then is maximal ideal of an R, F multiplicative, b-homogeneralized derivation associated with the derivation such that f of sigma tau minus plus sigma tau belong to Z of R, then either B acts as a centralizer of K or D of K, I mean home derivation of the Dennis maximal ideal equal 0. Yes. I think I still the problem of issue, but issue of technique. And the last, yes, this is theorem 7, last my result. Suppose R prime ring and K is a non-zero Dennis maximal ideal of R. F is multiplicative B homogeneralized derivation associated with the derivation, then B belong to Z of R, belong to center of the prime ring when when R admits F satisfy the following condition. Here this is sigma tau belong to K, typo here. Finally, this is for condition. Here bracket belong to Z. Here f of sigma tau minus plus sigma tau and Z. Here f of sigma circle tau, I mean here equal 0, and here the bracket Lie bracket here Jordan bracket equal 0, and all them we get B belong to Z of prime ring. Finally, I closed my slide or my presentation by the list of references. I believe they are a good reference to enrich information for any people or any researcher interest to get more information about the background of my subject. Finally, thank you so much, and thank you so much for the organizer to give me this great opportunity and help me to not lose my chance to attend this conference. Thank you again.